Hello everyone, welcome to Science Prodigy. Today we will be continuing language of chemistry of class 9. As you had seen last day, we discussed problems on relative molecular masses. So today we will be continuing from percentage composition and its calculations. Okay, so sit with a pen and paper and let's begin. So now what is percentage composition? When I say percentage composition, I am trying to find out the percentage by weight of an element present in a particular compound. So it is the composition of that element with respect to a particular compound, or the percentage of the element present in a particular compound. That means I can actually consider percentage composition as the weight of the given element in the compound by the weight of the compound into 100, because it is in percent. So I hope what is percentage composition, that is very much clear to all of you, that it is weight of the given element whose composition has to be calculated by the weight of the compound into 100, because it is in percent. So let us check some numericals to understand the calculation of percentage composition in a better way. Okay. So starting with a very basic question which asks us to find what is the percentage of hydrogen in H2O. So the moment we see this, the first thing is, percentage means first of all we have to go for the weight of water. So the weight of H2O is 2 plus 16 grams, that is 18 gram. And the weight of hydrogen here, you can see that there are two hydrogen molecules. So the weight of hydrogen is 2. So what is the percentage composition? Weight of the given element by weight of the compound into 100. So if we calculate, our answer comes out as 11.1%. So I hope you understood. It is very simple. Okay, so moving to the next question now. Now in the next question it has been asked to find the percentage of nitrogen in urea. Sometimes the formula of urea may be given, it may not be given, so it is better that you know it. It is NH2CONH2. So simply we will be going to find out the molecular formula of the compound. So GMM of NH2CONH2 is 14 plus 2 plus 12 plus 16 plus 14 plus 2. So upon calculation, it will be 60 grams. Now the mass of nitrogen, because there are two nitrogen atoms, so the mass of nitrogen will become 14 into 2, that is 28 grams. So the percentage composition is mass of nitrogen. So you will always have to write the formula and then you will be substituting the value in the formula. So 28 by 60 into 100%. So this value comes out as 46.66% or approximately 46.7%. The next question is to find the percentage mass of water in Na2CO3 dot 10H2O. So this sort of question where we are not asking to find the percentage mass of a particular element, but we are asking to find the percentage mass of the water of crystallization. So this question is also common question. You can expect this type of question in your exam as well. So let us begin. So what is the mass of Na2CO3 dot 10H2O? Evaluating this part is 180 plus 23 into 2 plus 12 plus 16 into 3 gram. The value is 180 plus 12. Calculating it, it is 180 plus 106, that is 286 gram. And what is the mass of water provided here? There are 10 such water molecules. So the mass of water is 10 times of 18, that is 180 gram. So the percentage mass of water is 180 by 286 into 100. Upon calculation, it is 62.9%. Okay. So I hope this, after discussing these three questions, it is very much clear how percentage composition is done. That is, the percentage composition of an element is generally asked, or for elements containing, for compounds containing the water of crystallization, the percentage composition of water is asked. It is the percentage in its composition, so its weight by the weight of the compound into 100, because it is a percentage. So I hope it is very clear. You have to practice certain questions from your own, 3-4 questions more, and percentage composition will become even more easier. So moving forward to empirical formula. So now beginning with empirical formula, it is often given in question that find the empirical formula of this particular compound, and the molecular formula is given to you. So for class 9 purpose, empirical formula questions are in a very easier format, which you can directly go by just reducing it to the minimum possible simplest ratio. But the moment you step into class 10, empirical formula calculations are also there, where you have to actually calculate it, evaluate the simplest ratio, and if it is coming in a fraction, turn it into a whole number and then get the empirical formula. So for class 9, it is a very basic level, a very beginner level of empirical formula, which does not require enough amount of understanding. If you just know what it is, know the basics of it, that's enough. So now first of all, what is empirical formula? As you can see, I have already written down the definition. You can get the definition in your textbooks as well. It is the simplest ratio. Okay. So simplest, but most importantly simplest whole number ratio of all the elements that are present in a single molecule of a particular compound. So I repeat, the only area where we have to stress on when we are talking about empirical formula is the simplest ratio, that is the minimum possible ratio in which all the elements of one molecule of a compound can be represented in. So in general for class 9, just a particular easy question will be provided. You just have to ensure that it is written down in the minimal possible ratio. We will be seeing certain examples and questions, and with them I hope it will be 100% clearer to all of you. So just seeing one basic example, okay, that is the most common example, glucose, C6H12O6, and you are being asked that write the empirical formula of glucose C6H12O6. So how will you write the empirical formula? You have to go for the simplest ratio, keeping in mind that it should be in whole numbers. So if I divide all of them by 6, I can get the simplest ratio as CH2O. Pretty simple. This is the empirical formula of this compound. Just ensuring the simple ratio is in whole numbers. That's it. Then if we move on to the next one, C6H6. What is the empirical formula of this one? Empirical formula is only CH. Simplest ratio CH. Okay. So then let us see certain questions which you will be doing on your own, and then empirical formula will become way more easier for all of you. Okay. So as you all can see, I have listed down 3 questions. You can even do them orally. There is nothing very difficult in them. You can see them and do them orally as well. That will be even more better. Don't try to do this with pen or pencil. Just go for it orally and it will be done easily. First one, C2H2. Find the empirical formula of C2H2. Very simple, CH dividing both by 2. The simplest ratio is CH. Done. So you can see that it's so quick. In the fraction of seconds it's done. Second question, CH3COH. If it is given in this form, always ensure that you actually go for taking all the elements in one place. What do I mean by that? I am taking C2H4O2. Okay. Both represent the same thing. Now tell me the empirical formula. Very easy. Maximum possible thing which it can be divided by is 2. So the formula is CH2O. This is the empirical formula. And for this one, it is just like the previous one. The empirical formula is HO. So with this, we complete language of chemistry, the first part of the first chapter of chemistry class 9. So empirical formula, this sort of questions will only be coming up. Percentage composition is also of this type only. Okay. So with this, we complete today's chapter. We end today's video. In the next video, I will be starting with the next chapter. So till then, keep watching and thanks a lot.